That's pretty easy, going through the basic stages of how a METAR is. Now, that was the basic, but this is a summer METAR, best case scenario. Something looking like this might also look like this. Suddenly it becomes a lot more advanced. This we will look into now. Now, if you did not understand the basic parts, please watch this again so you know that you know the basic points before continuing to the advanced. Now, let's look at everything again. The admin part is still pretty much the same, except some airports, especially in Denmark, you will see they have this auto standing. This means automatic observation. This means it's the difference between if it's a human making the METAR or it's a computer. Now, normally having a human doing the METAR, it can be more precise. Now, sometimes when you have this automatic, it means that there's a computer that makes the METAR. Next thing, you have the runway condition. Again, for now, we are gonna talk about the wind. Now, the wind can have very different stages. It can be steady. It can also have a gust on it. It can even be maybe a bit variable. Then also sometimes you will see the wind displays as variable if the spread of the wind is so big that it can't really measure a direct distance. So these are normally the different kinds of wind you can see. A steady wind with a gust, steady wind with a gust being variable, and also wind being so variable that there is no direction. If the wind is less than 2 knots, then you also have it considered to be calm. Now, you do have other specific runway conditions coming up at the end, but we will get back to that. Moving to the meteorological conditions. Now, we're keen on to the two subsections, which were visibility and the cloud base. But let's expand now on the individual ones. First and foremost, you'll see from time to time that the METAR has a suffix saying NDV. This does mean a non-directional variation. This comes when the METAR was automatic observation. This means a computer did the visibility calculations. Now, this is alerting the pilots that it was not really a human looking all the way around 360 degrees, but a machine taking one specific point and saying, here the visibility was 10 kilometers. So it's a difference between a machine doing it and a human doing it. Now, in addition to the visibility, you will get to learn a new term here, which is called RVR. This means runway visual range. And RVR is related to visibility, but it's kind of a different visibility. It's normally displayed when you have low visibility, and then this RVR will be measured, which is what is really needed for the pilots. Do you remember earlier when we talked about that visibility was a black spot on a white background? Now, RVR is for how far away you can see runway lights. And this is really what a pilot needs to see in order to land in low visibility. The RVR is displayed as follows. It's displayed as a runway, then it's displayed as the measured RVR, and then it also have the tendency. The tendency can be either upgoing, it can be downgoing, or it can just stay neutral and have no change. Now the RVR continues displaying until it reaches 2,500 meters. After that, you'll see this P coming up, meaning essentially it's plus 2,500 feet, so more than 2,500 feet. Another thing that can be displayed is conditions that affect the visibility. This is the best example of is precipitation. This can be something as rain, it can be snow, it can even be hail. These are the most common ones. Apart from the type of precipitation, you will also have the intensity of the precipitation. These can mean a light, then you have a minus before. It can be moderate, then you just have nothing. Or it can be heavy, and then you have the plus. Other conditions that you might have can be things that limit the visibility around you. This is normally something like haze, it can be mist, or it can be very low visibility, and it can be fog. As you may imagine, there are countless additions and alterations that you can put. You can put something as blowing snow, it can be shallow freezing fog. There are typeless amounts of different combinations which you can read about in the training content. Moving to the cloud base, there are variations as well. Most predominantly, it's certain types of clouds will get a suffix to explain the severity of the clouds. There are two different kinds. The first one is the towering cumulus, which is basically a big going up high cumulus, or you have the biggest one, which is the cumulus nimbus, made like CB. It's mainly look like this in a METAR, having the suffix there at the end. Now, of course, you can also have the situation with very low visibility, but then how high does the cloud look in this picture? If you think about where the clouds are here, it's just impossible to say. You have a very low ceiling, and at some point you can't really say where it starts, and then it becomes what is known as an indefinite ceiling. Low ceiling, you normally have it's easy to see. You can see up 500 feet, then the broken cloud starts. With an indefinite ceiling, you will instead have the vertical visibility, or known as a VV 005, meaning that you can see 500 meters up into the air. VV, called vertical visibility, you will see when you have this low vis and therefore an indefinite ceiling. Now, moving further along, you have the temperature and the QNH. Not much change here, except of course you can have minus degrees as well. And lastly, of course, you have the trend. We already went through the different trends. Another one which might be a good thing to know is when you have the RE comes as a trend. This is not a prediction of what will happen, but something that has recently happened, as recent rain or maybe recent snow. Moving along, we have this one at the very end. Now, this is back to the runway conditions. This is what is known as a METAR code. A METAR code is a part of a SNOWTEM, used a lot in the northern countries like Norway. We will not go through the entire SNOWTEM here as it's not really that important. We will only focus on the very METAR code. This report is basically telling you what the runway surface conditions are. It normally comes up as an 8-digit number, which can look, for example, like this. Now, what does it mean? Well, you break it up into 5 different categories. Now, first of all, you have the runway number concerned. In this case, it will be runway 04. And this has a lot of variations. You can add 50, and then it means the parallel runway, the right runway, or it can be code 88, and it will be all runways. Now, this will be hard to explain, so there is a table, you can find it in the training content as well, telling you exactly how to decode the METAR METAR format. Then the next one you have is the type of deposit, which you have here. For example, in this case, it would be number 5, which is wet snow. The third group you have is the extent of the contaminant, basically how much of the runway is covered. Now in this case, which was 2, which means about 11 to 25% is covered. The fourth group you have is the depth, measured in millimeters. As you can see here, 0.3 is about 3 millimeters. The fourth one you have, which is the important one, is the braking action. Now, the braking action is what the pilot really needs to know how well he can stop. And it's breaking into 3 different categories, which is good, medium, and poor. Well, then you have 2 more, which is kind of in between. As you can see, the table here below you tells you exactly what it means. Now, in this case, 47, it means the braking action is good. This is very complicated stuff, and it does take some time to get into. Look into your documentation, have this quick sheet, and then you can recognize the codes once you sit in an